What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Today, we're going to be talking about a fun little reaction that I saw in Chem 118C with Dr. Nasiri. So let's go ahead and jump in. We have an aldehyde group, and we're looking at step number 1 here, okay? So I see a poor nucleophile in excess with some HCl, okay? So I'm thinking if we're working with a carbonyl system, we're going to need to charge it up before we can react with a poor nucleophile. So let's go ahead and see what happens when we do that. So we got some HCl floating around. This O can grab some HCl. Let's go ahead and look at what we get here. Let's see. Here's our OH positive group. The group just like that. We got some Cl minus floating around. Okay, and now we have that poor nucleophile, okay? So now this can come, hit that carbon there. Let's go ahead and see what we get. So now we have an OH group with a new lone pair on that. We still have our carbon system coming off of there. And now we have this CSH group. We have this sulfur. This sulfur is directly attached to this carbon and then has a CH3 and a hydrogen coming off of it. Okay, so that means this is positive. So how can we fix that? How can we get rid of that positive charge? Well, this oxygen here, being a good base, can come grab this hydrogen and push on a lone pair, right? So we had one lone pair there on the sulfur, but we want to make it 2 lone pairs. So what do we get? Now we have OH, H, 1 lone pair plus. And we fixed that sulfur is now happy. Got the CH3, and we still have our carbons. Great. So since we are in excess of CH3SH, I'm predicting that now that we have a good leaving group, we have that water group here. This is our good leaving group. I can take some more CH3SH and I can react it right at this carbon and kick this good leaving group, kick it on out of there. So now we get some water and we get H with an SCH3 group and another SCH3 group with a hydrogen and a positive charge. Okay? And then here we still have our 2 carbons. Okay? So in this, let's see, in this step here, we form some, in this first step, we form some Cl minus. So we have Cl minus floating around. This can come grab our hydrogen and fix this. So now we have hydrogen, SCH3, SCH3, and we have 2 carbons. Okay, so what do you think is going to happen now? So we have 2 groups here, and we have a CH3CH2 Br. So let's go ahead and see. Oh, so we're looking at this next step here, okay? We're on step number 2. We have an NBULI, okay? Now, we don't need to know exactly what it is, but we do need to recognize that it's a big, bulky base, okay? We got a big, bulky base. Now, what this is telling me is it's going to look something like if we had a lithium out in front and maybe we have an Al group like this, or maybe we had turbietoxide and we had a big O- group attached to a carbon that had 3 CH3s coming off of it. These are really bulky, which means that they're not going to be able to go into a fine, tight little space. They're going to want to attack something that's really out of the way. We're going to want to attack a hydrogen that's maybe going to give us some electron density. That's going to give us a lone pair. Maybe it's going to give us a double bond. So let's see what happens. So if we took this negatively charged species, it doesn't really matter what it is. We just need to know that it's a big bulky base. Then we can take this, we can come grab this hydrogen. This bond in here can break, and it can go right onto our carbon. So what do we get? Now we have, here's our ethyl group. We have our SCH3. These are basically protecting groups, and we'll get to that in a different video, but just keep that in mind, okay? And we got a lone pair there, which puts a negative charge on our carbon because it wants to have 4 bonds. Right now it has 5 valence electrons. So then if I react this with step number 3, here's our CH3, CH2, and our Br. I see a good leaving group, and I see some partial negative charge pulling on the carbon, making this partially positive. Nucleophilic attack on the electrophilic carbon. What's that going to give us? Well, it's going to give us our SCH3. Here's our SCH3. And we have our ethyl group. Now we have a new ethyl group, right? We have 1, 2 carbons. We have carbon number 1, carbon number 2. That's great. So that'd be our left. Our last step here is working with H3O plus and HCl2 and heat, okay? Now the main thing to take away from this is that this group right up here is basically a protecting group. And we can get rid of a protecting group by heating it up and putting some H3O plus. And what do you think that's going to give us? Well, we don't need to know the mechanism for it, but we need to know to get rid of a protecting group such as this group, or perhaps we could have had something that looks like this. Maybe this would be more familiar for you guys. Something that looks like that. Both of those we can react here with our H3O plus, our HCl2, and our heat, and we can go ahead and get a carbonyl. Okay, so it gets rid of those protecting groups, and we get our carbonyl. And now this is our final product, okay? All right, guys, thanks for tuning in. See you next time.